Okay, short video lesson on expressions in algebra. Expressions. An expression is a way of saying how much something is. Just to put things in perspective, so in algebra, when we're dealing with algebra, there are three types of statement that we might come across. An expression is a way of saying how much something is. So here we've got three examples of expressions. First one, second one, and third one. This one we call a linear expression. This one is a square or quadratic expression because there's a square or quadratic c there. This one's a cubic expression. We have c cubed there. So three types of expression. We also have, in algebra, we have things that we could call relationships or rules or functions or formulas. These are four different words here, but are describing the same kind of statement. A relationship, rule or function or formula, is a way of saying how two or more things are related. So this is a relationship here between x and y. If you tell me what x is, I can work out what y is. It shows a relationship between x and y. Here's a formula, you could call this, or a rule or a function. It shows how to work out the area of a circle from the radius of the circle. So that's a relationship between the radius of the circle r and the area of the circle a. This is another relationship. This shows how to work out the volume of a cuboid from the length and width of its base and the height and its height. So this is a relationship between, in fact, four things: the volume, length, width, and height. An equation is a way of saying how x is related to numbers we know. So down the bottom here are three equations: a linear equation, a square or quadratic equation, and a cubic equation. So in an equation there's an equal sign, but there's only one variable or unknown. Quite often it's x, doesn't have to be x, but quite often it is. So there's only one unknown, just one unknown, just one unknown. So an expression never has an equal sign. It's just a way of saying how much something is. It doesn't need an equal sign. A relationship, a rule, function or formula generally will have an equal sign. The exception to that being is if you were using a flow diagram or arrow language, when you could show the relationship using arrows or a flow diagram. An equation will always have an equal sign, but will only have one unknown or variable in it. Right, moving on. To say something as an expression. So just a quick recap. There are 6 operations in maths. We have add. You first of all learned about adding and subtraction, then multiplication and division. They build on that, on those two, and then finally powering and rooting, which build on the ones below it. So as an example, Alan has C counters. If someone has 2 more than Alan, so Alan has C counters, somebody has 2 more, that's kind of addition, and that's the way you'd write that in as an expression in algebra would be C plus 2. The other person would have C, you would say, has C plus 2 counters. If someone has 2 less than Alan, so if Alan's got C counters, if someone has 2 less, then you would write that as C subtract 2 counters. If someone has twice as many as Alan, the way you'd write that is that you'd say that they have 2 C counters. So in the expression 2C, there is although we can't see it, we understand that there is a multiplication sign between the 2 and the C. That means 2 times C, or 2 lots of C. If someone has half as many counters as Alan, you'd write that as C divided by 2, or C shared between 2. So the idea we're using there is the idea of division. Changing tack slightly. Here's a square. The area of this square, how you would say what the area of this square is in algebra. To find the area of a square, you multiply this length by this length. So C times C, we're writing that as C squared to write it in a shorter, quicker way. So that's an expression for the area of that square. And if you wanted to square root C, you'd write it in that way. So what we got here is 1, 2, 3, 4, 5, 6 different expressions, very simple expressions, but all they're doing is saying how much something is. So that's what, in essence, what an expression does. It tells you how much something is. An expression can be linear, which would mean that the highest power, there are no powers of C other than just C itself, so there's no C squared or C cubed or anything like that. This is a square or quadratic expression, 3C squared. The highest power is a power of 2. This is a cubic expression because the highest power is a power of 3. Just this does link in with measuring units if you wanted to, to prevent you from forgetting. we have linear centimeters, square centimeters, and cubic centimeters. So the words linear, square, and cubic crop up in measurement, but also crop up in describing things in algebra. To find the value of an expression, we may need to do this for a variety of reasons. For example, working out if this was the formula, for example, for figuring out the perimeter of some shape. You might say P equals 5a plus 7b. In order to find the value of an expression, we have to understand what the expression means. So 5a means 5 lots of a, or 5 times a. There's no multiplication sign shown there, but we understand that it's there. Similarly, 7b means 7 lots of b, 7 times b. There's no multiplication sign there, but we understand that it's there. Now, we have to remember the order of operations. We have a multiply there, and an add. We do the most powerful operation first. The most powerful operations are the two multiplies. If we have two equal ranking operations, we work left to right. We do that one first and then that one second. You may want to rewatch the video lesson on the 6 operations and which ones to do first. So that's a separate video lesson. You may want to rewatch that. So we do this operation first, 5 times a. 5 times 3 is 15. So what I'm using here is an arithmetic tree just to show what I'm doing, but also acts as a very good way of showing somebody who's reading your work to see what you did. Now the second multiply, 7 lots of negative 4. 7 lots of negative 4 is negative 28. A positive times a negative is a negative result. So you may want to rewatch the video about operations with negative numbers. Now the only operation left to do is the add, so we have 15 add negative 28. Adding would normally take you up, but because we're adding a negative we go down, so 15, then going down 28 will take you down to negative 13. So you may need to rewatch the video lesson on handling negative numbers. More complex expression. So we have powering, we have a multiply there, addition and an addition. The most powerful operation is the powering, so do it first. Take the value of c and square it, multiply it by itself. So c squared, that means, take c and square it, negative 3 times by negative 3 is positive 9. Then you have two multipliers to do, 4 times c squared and 5 times c. Work left to right, do this multiply first, 4 lots of 9, 4 lots of 9 is 36. Do this multiply next, 5 lots of negative 3. 5 lots of negative 3 is negative 15. We now have two additions to do. So this addition and this one, we work left to right, do this one first. 36 add negative 15, it will give you 36 adding would normally take you up, but because of that you go down, so you go down to 21. And finally you have this addition to do, so 21 adds 7, 21 adds 7 is 28. So that the value of that expression when c is negative 3 is 28. The value will fluctuate depending on what c is, but for that particular value of c, the value of the expression is 28. If the value of c was 4, if the value of c was 4, the value of the expression would come out to be something completely different. Right, one thing that we often have to do with expressions is to rewrite them for different purposes. So what we're doing here by itself would seem slightly pointless, but it's about becoming fluent with algebra. So we're going to rewrite expressions in different ways, sometimes just to make them simpler and easier to work with, but sometimes for reasons which will become clear when we move on to working with relationships and with equation solving. Right, if we have one lot of a, add another, and another, we have 4 lots of a there added together. So we have 4 lots of a, and that's how we write it in a simpler way. There's a multiplication sign between the 4 and the a. We understand it to be there, 4 lots of a. This, however, is very, very different. This is a multiplied by itself 4 times. When you take something and multiply it by itself, that's called powering. So we need a to the power of 4. That's why we can write this in that way, which is very, very different from the one above. Here we have 2 lots of a, add 3 lots of a. That, if I speak it to you that way, I think it'll become clear that the result is 5 lots of a. If, however, we do this is very different. This is 2 times a times 3 times a. Here is the expression written out in full with the multiplication signs inserted. Multiplying does not care about order. So put the 2 and 3, with this chain of 4 things, imagine the 2 and the 3 at the front of the chain. So 2 times 3 times a times a. 2 times 3 we know is 6, and a times a we know is a squared. And the multiplication sign between them, we can choose not to write that. So we can just write it in a very compact way as 6a squared. This one here, we can only add and subtract things in maths that are alike. So we can add 2a and 3a to give us the 5a. You may want to draw or imagine a bubble around the negative sign with the 6b to ensure that you keep the negative sign with the 6b. So 2a plus 3a is 5a, but 4b subtract 6b is negative 2b. The last one here, this is a multiplication chain, 2 times a times 4 times b. 2 times a times 4 times b. Multiplying doesn't care about order, so put the 2 and the 4 at the front to get 8, and then 8ab, which is why that's what's showing there. Another way we have to rewrite expressions is expressions that have brackets in. We sometimes have to rewrite so they do not have brackets. When we're multiplying 3 lots of 81, some people split the 81 into 80 and 1 and do 3 lots of 80 and 3 lots of 1. In a similar way, here what we have to do is 3 lots of 2p and 3 lots of 3. 3 lots of 2p is 6p and 3 lots of 3 is 9. So that's how we rewrite the expression in that case. Some people, when they're multiplying 23 times 45, will split the 23 and the 45 like that and use the grid method, some sort of grid method, to draw some sort of rectangle thing which has 4 parts to it. The key thing is that there'll be 4 parts to your answer or result. 20 times 40 is 800. 3 times 40 is 120. What else do we have? We have 20 times 5 will make the 100, and 3 times 5 will make the 15. The key thing is there must be 4 parts here to the result. In a similar way, if you draw a grid and try and handle these in a similar way, x and 3 and x and 5, x times x is x squared, that times that gives that times that gives that, and 3 times 5 gives 15. In maths, you can only add or subtract things that are alike. These two are alike, and they can be added. That's why we can write it in a slightly neater way, simplifying it like that. Finally, factorizing, rewriting expressions by factorizing. Factorizing is finding the factors. Factors are the things you multiply to make something. If you're asked to factorize 15, you have to think what goes into 15, and the most likely thing that people would write down is 15 equals 3 times 5. If you're asked to factorize this, you have to think what goes into 10 and into 15. And 5 will go into both those things. So it's going to be 5 times something, but what's the something going to be? If you think about it, there's no way it can be a single thing there. It has to be a 2-part thing. So 5 times what makes 10p. The only thing that can go there is 2p. And 5 times what makes 15. The only thing that can go there is 3. So that is how you factorize 10p plus 15. If you're asked to factorize this, then it's going to be, if we're going to find factors, we have to find 2 things that multiply together to make that. And if you look at the previous slide, if we go back to here, we'll see this thing here will help us to figure out how to factorize x squared plus 8x plus 15. X squared plus 8x plus 15 can be made by multiplying x plus something, and there's somethings there have to be x plus 3 and x plus 5. So that one, at first sight, you think what goes into that and that. Nothing comes to mind initially. So it's quite different factorizing to the first one. Here you need a bracket times by a bracket, a 2-part bracket times by a 2-part bracket. And that's where we'll leave it. Thank you.